Okay, so the last set of operations is addition and subtraction. We're going to group them together because the way that you do them is the same. Now, if you had a fraction, something like that, you can't just add them together, right? You need to find the LCD first. So in order to find this LCD, you take the denominator and you find its factors, and the other denominator and find its factors. The exponent, the highest exponent of each of those numbers, you write in the LCD. So 7 to the 1, 1 to the 1, and 5 to the 1. This is the LCD here. Okay. And now that changes, right, depending on if there's, like, for example, a 7 here and like a 7 squared. This would change to 7 squared instead. So we are missing here a 5, and we're missing here a 7. So you get 10 over 35 plus 21 over 35 is 31 over 35. Okay? Now, remember, we needed this LCD in order to add them, right? And if you haven't been shown this, the reason is quite easy visually. So, for example, if I add this to that, it's pretty easy to see that that's going to be 3/4, right? You don't even need to do the math to visually see that that's going to be 3/4. But visually, what if I give you something like this? Add that to that, which is 1/3 and a half. Well, that's not very easy to see how many slices we have, right? But if we rewrite it, so the LCD is 6, right? This is going to be like that. And like that. These slices are all the same size. So how many slices do we have? 1, 2, 3, 4, 5. So this is 5 slices of size 6. Okay. So this is the reason why you need the LCD, so that you can actually just count them. What you're really counting is 5 1/6 pieces. Whereas this is 1 1/3 piece, this is 1 1/2 piece, but they don't add together very nicely because the sizes of them are different. So that is what we're going to do when we're discussing the LCD of polynomial functions as well, or sorry, rational functions. So let's go ahead and look at that. What you're going to do first is factor. Okay. And in this problem, it's already done. Okay. Number 2, instead of, we're going to find the LCD. And we're going to list it out by writing out each of the different elements of the denominator and the highest exponent of them. So the LCD here in this problem, notice is x plus 1, because there's an x plus 1 there, and x minus 1 there, and the other one has an x. Okay, and the highest exponent of each of these different ones is 1. So we can leave it like this. This is the LCD. Okay. You don't need to multiply it out, you don't need to do anything to it. That's the LCD. Step 3 is multiply the top and bottom of each fraction by what it's missing. Kind of like what we did when we were doing the other fraction, 7 was missing a 5. So here, this x plus 1, x minus 1 is missing that x. So I need to multiply the top and the bottom by x. This one is missing x plus 1, x minus 1. The bottom is x plus 1, x minus 1. So we're multiplying each of these fractions by 1. And when we multiply fractions, they multiply straight across. So notice that when you write this out, now the bottom is the same. Okay, so once we have the bottom is the same, now we can use the same rules that we did when we did regular fractions. Add or subtract the top, leave the bottom. So x minus 2x, x plus 1, x minus 1, all divided by the bottom. Okay. Now, a lot of you may be tempted to cancel here, but remember, cancellation over division only happens when the top is multiplication, similarly with the bottom. So if you want to try to cancel something, you first need to do all of this distribution and see if you can factor it again, because factoring is what turns the polynomials into multiplication problems.